Good afternoon, students. I'm Rohit. I'll be taking this live interaction session 12 of NPTEL. So this course is Sustainable Power Generation System being taught by Professor Pankaj Kalita. He is Associate Professor in IIT Guwahati. And I'm Rohit. I'll be taking this live interaction session being conducted on 15th of October 2024. So far so good. I think this is the live interaction, last live interaction session of this course. So I hope you guys have gone through the weekly lectures that is being uploaded on the NPTEL. And if you have any questions, so please feel free to ask your questions, or you can type your questions on the chat box also if you are shy in asking your questions. Otherwise, if you think your question can benefit other audience also, so I will suggest that asking on the discussion forum can be a good thing in that case. Okay, so I hope your preparation for the final exams are going well. So even if you think that some questions need discussion or something, so please feel free to write to me at my email address also. Okay. So I think it's already 7, and let's start this session. Okay. Okay. So this is me. I think you know a bit about me now because it has been 12 weeks now. So live session teaching methodology. So we meet every Tuesday from 7 to 9 p.m. And basically I had discussion on the topics taught in the weekly lectures. So apart from that, we have doubts clearing session also, interaction with the students also. So these are some of the things that we do in the live interaction session. Apart from that, if you have, we generally encourage a student to ask questions in the live interaction session itself. But if you have any questions and you think that you can ask it for a better audience, or you want the answer from the professor himself, so please feel free to ask on the discussion forum also. So that is also there. That option is also there. And as far as the live interaction session is concerned, use the chat box and discussion forum to get your queries addressed. So so far, we have seen from lecture like week 1 to 11. So we discussed all the different types of renewable energies or non-conventional energy sources. So we had a discussion on the solar, we had a discussion on the wind, ocean thermal, wave energy. So these are very non-conventional type of energy. You don't see wave energy being harnessed to supply electricity to the cities. Okay, so these energies, if you want to put on a large scale, so that requires a good amount of research also, because all these energies are in various TRL levels are there, technological readiness levels. So some of them are on the TRL 7, TRL 8, TRL 9, but yeah, many of them are actually demonstrated. So yeah, you can get the electricity or the power in form of something or other thing, or you can store the energy and then that stored, like we saw in the case of compressed air. So wave energy was used to compress air, and that compressed air can be used to actually run the gas turbines and generate electricity. So that is also a case. Okay. So this is not the case that the first energy will be generated and then it will be stored. So stored energy can itself be used for generating electricity. Now, if we see important graph here, we have two important graphs, both taken from Energy Outlook 2023 report. So one is for fossil fuels. So we see that out of all the fossil fuels, I think these three lines are not demarcated here properly. But let's say this one is basically for some scenarios, or maybe this one is coal or this one is gas or something. Okay, but generally they are sharing a same color, so maybe some scenarios will be there. Okay, so if we see, compare it from 2019, so and we see the scenario till 2050. Why 2050 we are considering? Why 2050? So can any one of you can answer why it is 2050? Think, and let me give you some time to think and search on Google why do we study, or why most of the graphs for energy, or you say energy mix, are going towards 2050 only. So let me tell you the reason. So basically, UN had declared 2050, targeted 2050 to be the net zero emission year. Okay, so whatever emission coming from the fossil fuel, so similar emission will be avoiding because of the usage of renewables. Okay, so it will balance out. These two emissions will balance out, and 2050 will be the net zero year. But in different countries, so this is kind of what you say a target to achieve, but different countries have different targets. Like for India, 2070, India has put a target of net zero in 2070. So similarly, other countries may have some other targets. Some countries may not have any target at all. These can also be there. So you can see from 2019 to 2050, the share of primary energy, basically the fossil fuels, are decreasing. And on the similar context, we see that the share of renewables, that is air, wind, water, solar, etc., is increasing. So if you check these two graphs are showing a similar pattern with similar type of increase. So basically, whatever the place will be vacated by the fossil fuels will be taken up by the renewables. This is the kind of energy mix which we are going to observe in the future in 2050, and there will be a drastic change in the energy mix also. So if we see compare the energy mix of India nowadays, so most if we compare it capacity wise, so yeah, a lot of like some 20 to 30% are now being contributed by the renewable energy. Okay, but the problem here is the capacity utilization factor is very low. So if you go to the generation, so still coal is the king. Coal power plants are supplying 75% of the total electricity. So this is the data which you need to take in mind. So generation and capacity are very different things. Okay. So plant may have a capacity of 250 megawatt, but it can generate only 100 megawatt hour of electricity. So that has to be taken into account. Okay. Now the thing is, if we are using these different type of resources, what are the levelized cost of energy? Whether these are actually beneficial to use these type of energy, or is it not beneficial? Okay. So we compare according to different parameters like levelized cost of energy. So there is techno-economical assessment is also there. So levelized cost of energy basically represents the present value of the building or operating a plant over an assumed lifetime, expressed in real terms to remove the effect of inflation. So basically, uh, I would say I would likely suggest that the levelized cost of energy. So if let's say if a plant has to be built and takes 50 crores to build, but because one thing is 50 crores, okay, the value, but that 50 crores will be spent over a time duration, like let's say the plant will take 5 years to build. Okay, or when if you add the operating cost also, so that will take around 50 years. The generally coal power plants operate till 50 years the lifetime. So whatever is the value of 100 rupees now, it, the value same value will not be there after 50 years. So let's say if you are buying uh, a thing, let's say a 1 kg of apple for 100 rupees now, but after 50 years you won't be able to buy. Maybe and for that you will have to pay 500 or 600 rupees. So that has to be taken into account, levelized cost of energy. So it divides the total cost into uh, throughout the year, and that is adjusted for the real terms, not to remove the effect of inflation. Okay. So levelized costs are then divided by the total energy obtained to allow direct comparisons across different energy sources. Okay. So basically a normalization is done. The cost advantage of fossil fuels over renewable energy sources has been decreasing in recent years, because I can give you an example uh, in terms of pricing. So earlier, what used to be there, that if you generate electricity earlier, I mean 2 decades ago. So if you want to generate electricity from solar photovoltaic cell, that cost around 22 or 23 rupees. Maybe it was earlier 48 rupees also, as far as I remember. 48 rupees for 1 kilowatt hour, 1 unit of electricity. So that's a huge amount. You are getting, I'm talking about generation source. So you are getting 3 to 5 rupees per kilowatt hour at the generating plant itself. And then you are talking about, let's say 20 to 25 rupees of electricity. So who is going to purchase? But now the recent contract standard, the price has fallen as low as 2.2 rupees per kilowatt hour. So it is even lower than the fossil fuel power plants. The reason is because when you build these solar PV cells power plants, so these are one-time investment and their operation and maintenance cost is low. You don't have to put fuel like coal. The whole logistic chain is not there. You just have to put the plant and then the electricity will be generated and that can be transported. Okay. So a whole backend support is not needed in case of solar photovoltaic cells. Certain renewables can already compete with fossil fuels solely on financial terms. So this is what I gave you an example of. And renewable energy costs are expected to decline further in future while fossil fuel prices will likely rise. The reason is because fossil fuel prices will rise because inflation. One thing is that the value of money is going down because of inflation. Second thing is that even nowadays you are extracting coal at, let's say, 500 meter below the earth's surface or 1 kilometer below the earth's surface, but after 10 years you are not going to get coal at 1 kilometer. You have to go deeper and deeper, similar for petroleum, natural gas, everything. So that will add to the cost of the, and then logistics are there, everything is there. So that will actually affect the price of fossil fuel. And because renewables are generally free, solar energy is free, wind is free, so that is going to hamper and disrupt the uh, electricity supply chain. Okay. So if you have any question on this, please feel free to ask. Okay, so if you have any questions, please feel free to ask. Okay, guys. So if there are no questions, should we move ahead then? Okay, thanks. Now there is net energy ratio. So net energy ratio normally expresses the ratio of the energy available for final consumption to the energy required to produce it. Okay, slide so more. Okay, so net energy normally is a ratio of energy available for final consumer to the energy required to produce it. So a large net energy ratio means we get a lot of useful energy for small energy investment. So if net energy ratios, if we check for different, oil is 35, coal is 80, hydropower greater than 100. So you can see photovoltaic cell at 6.8. Okay. So there are different things. Cogeneration. Cogeneration is basically, if you see cogeneration means you are generating electricity using two different processes. So it can be two different cycles, it can be two different power plants combined together, like you can say steam turbine cycle and then gas turbine cycle clubbed together. So it's kind of like this. But if you see cogeneration, so that was combined cycle. Sorry, the cogeneration is basically when you are producing power and thermal energy, power and heat using the same fuel. So what it is done? So you have a boiler and then you have a turbine, and whatever electricity generated is given through the generator, and then whatever enthalpy is there in the steam, so steam even after passing through the turbine, steam has got a good amount of enthalpy, so that can be utilized in some process heat application, like in case of some industry, like textile industry uses the steam to have a cleaning agent or something, and then we have automobile industry also. So there are a lot of applications for the steam, heated steam. So there is a process heater where you can extract that energy from the steam and then use it for the purpose, and then whatever is actually remaining is going to the condenser or some pump and then flow it back to the boiler. Similarly, in the case we also have cogeneration with pass out turbines. So the difference here is basically you bleed the turbine itself or take out the process heater. Okay, so that goes into the boiler using the different arrangement, and the remaining steam actually passes through the condenser. Okay. Next slide, the condition for feasibility of a cogeneration plant. So this is very important. So a cogeneration plant, so you have a heat input Q1 and then output as W2 and process heat as QH. So you can say that the efficiency of cogeneration plant will be WT, that is work turbine plus QH upon Q1. Now consider two separate plants, one of which is producing QH and other is delivering the shaft work. Okay. So net output will be WT plus QU, and then for a similar combination of two cycles, so there are two different efficiencies, one for electrical, one for thermal. So input will be WT upon NE for electrical and QH upon NH upon for uh, thermal. Condition for feasibility of cogeneration plant. So E equal to WT upon QH upon Q2. So similarly, and then feasibility of cogeneration will be when NCO is greater than NC. So this is NC actually, E upon N, E1 minus E upon NH. Okay. A cogeneration plant is only advisable for from an economic viewpoint if the cost of electricity generated is less than the purchase from the utility system. Okay. And if the utility system is not available, then cogeneration becomes necessary irrespective of the cost of the generation. And a very low value of E is not economical for cogeneration. So E should have a specific value because work turbine should be there. Okay. Now, before I move to combined cycle plants, so if there are any questions on cogeneration, please feel free to put it here and see if there are any questions. So no questions. Okay, so I leave you guys with this slide for 1 or 2 minutes so you can have your questions, queries raised here. Okay, no questions from here. So, okay, so combined cycle plants. So heat discharge from one heat engine is not wasted to atmosphere but serve as a source for next heat engine. Okay, so this is kind of combined cycle plants are there. So one of the heat is actually recovered to run the gas turbines, and by superimposing a high temperature power plant as a topping on it in a steam plant, higher thermal efficiency can be increased because you are tapping the waste heat. Okay, so this is kind of a GT plant. You can say GT solar ST plant. So solar can also be utilized to run the plant. Now we are actually moving into the economic portion of the this like techno-economic analysis of the whole system. So economics is governed by rule of demand and supply. That this is rule of free market. So if there is no interference and if supply drops with respect to demand, so price is going to rise. Simple thing. So let's say let's take the price of onions or tomatoes in the market. So if there is a demand of onions and tomatoes in the market and supply is not there, supply is dropping, so simple thing, the whatever is left in the market will be sold at a higher price. So this is kind of a supply demand gap, you can say. And then if demand exceeds supply, so prices, if demand exceeds supply, so prices will rise. This is simple. So demand has to be controlled to control the price rise. The equilibrium price is at which supply exactly matches the demand. So this is called the equilibrium supply. Like you see in case of onions, and let's say you take a example of onion. So in generally in normal market of small towns, onions are basically throughout the year they are priced somewhere between 25 to let's say 30 to 40 rupees. So this is kind of equilibrium price because the supply is matching the demand. But once you have a lot of supply, then this price will go down because you cannot store onions for a lot of time. And then and there is a lot of demand and supply lows, and it can go up to 70-80 rupees also, like you see in this case these times. Okay. Now here it's saying that if there is a moment supply is increased. Okay, so supply is increased, so this is kind of a new equilibrium. Okay, because the quantity is actually decreased for the, so supply moves to the leftward side, and similarly demand moves to the rightward side, so that will also push up the price. Okay. So before I go into capital investment and other things, so if there are any questions from these two slides, so please have your questions. Okay. Let me see if questions. So if there are any questions, please feel free to ask. Okay. can be pictured as expenditure from which benefits can be expected in the long term. So most energy saving schemes require an initial investment. So initial investment will be required for, like in case of power plants, so they require a huge investment. So that is called capital investment. And monetary value of the savings, which will be invariably show a reduced fuel cost, must recover the initial cost in a short time. So if initial capital is borrowed money, then interest will be charged. So that also has to be taken into account, because interest charges are one of the two types, simple and compound. Two types of interest are there, and that has to be taken into account, because at the long term, the borrowed money can be can lead to a good good amount, accumulate into good amount. So there are different terminologies also, like principal amount of money considered initially. So that is the principal amount. Okay. So if you are borrowing a capital, let's say a huge investment for building a power plant, so you need some like 100 crores or 500 crores of money. So that is called principal amount. Interest is payment made for an amount borrowed from a bank or financer. So if you are borrowing from a financing company or say bank, so that you have to pay interest. Okay. Cost of capital in minimum rate of interest an investor expects to earn on their investment. Okay. So something like investor investing a certain amount of money into your project. So they will kind of expect some type of return as a rate of interest or something. So that is also counted into the cost of capital. Then we have number of time periods. So number of time intervals over which money is being borrowed or invested. So that is called number of time periods. Salvage value. So revenue attributed to disposing of the investment at the end of its useful life. So let's say you have invested something like 500 crores and then you build some power plants, but uh, at the end of investment period, useful life, let's say 50 years, the power plant is no longer able to produce some power, or maybe the technology is outdated, then you need to dispose that investment at the end of its useful life. So that is basically salvage value. Now we have interest rate terminologies like interest rate, a measure of productivity of money as a resource, or measure of investors' preference for the. So interest rate is kind of a opportunity cost. Okay, so something like you are going to earn that earn money for your principal amount if you have invested some other place. So a kind of opportunity cost, you can say. So measure of productivity of money or resource. Simple interest rate directly proportional to the capital involved, interest rate, and the number of interest periods. So it's like compound interest is like the interest whatever is earned. So the next time that interest is added to the principal, and then the interest next interest is calculated on the updated value. Now, before moving going to the payback period and simple payback period, so if there are any queries or any terminology which you don't understand, so please feel free to ask here. Okay. Now let's say you have borrowed some money, some capital, and then you have built a power plant, and then you need to run this power plant for a specific time duration for which it is built, and after that whatever investment which you have made for a specific years, so that you need to take into account, like how much after how much time this investment will come back after considering all the interest rate, all the discounted rate, everything. Okay, so that has to be taken into account. So a payback period refers to the number of years required to recover the initial outlay of investment. So that is basically an initial outlay of investment. So, and a simple payback period is obtained by calculating the number of years it takes for cumulative cash receipts equal to the cash expense. Okay, so basically BN, if you denote as BN as cumulative cash received because of the sale of electricity or basically usage of codings, advertising, everything. So whatever money is coming out in case. So here, if it is given as cash receipt, doesn't mean that the receipt has to be in cash. Okay. So and equal to cash expenses. So whatever expenses you are going to have. So let's say I have a question here. A proposed solar PV street light costs 15,000 for the last and last for 20 years. Okay, so because you are going to build a solar PV street light one at a time, it is not like a investment that will span for 3 or 4 years. So if a 15,000 investment is needed for a solar street light PV, and the saving electricity is estimated at 2,000 per year. So estimated payback period of the proposal will be 15,000 upon 2,000. So like 10.5 years you are going to get your investment back. Okay, so in case of these heavy capital intensive projects, the payback period is very important. So in how much duration of time you are going to get your investment back. Okay, so that is very important. And then we have discounted payback period. So this accounts for the changing value of money over time, because the reason here of considering discounted payback period is because the 100 rupees value which is today will not be the same value over the time. Over the time the value of the money changes. So this is the criteria with taken into account in calculating the discounting payback period. Okay, so NDP is basically n satisfy the below equation. So Bn minus Cn, and then 1 upon 1 plus I upon n is equal to 0. So this has to be satisfied. Now the cash flows for the three projects proposed during their lifetime of 3 years is given below. So calculate the simple payback period, discounted payback period, if the rate of interest is 10%. So take this question and solve this question. So I will give you some 5 minutes or something. So let's see if you are able to do this question or not. Okay. Okay. Okay, so are you able to solve this question? Okay, so if you want to solve this question, first you have to make a cumulative cost. So let's say, let me take a cost that will be needed. So let's say this is minus cumulative cost for this is 2400. Okay, then minus 1700, similarly 1000. So I'm writing only first two digits, I add the second digit. Okay, minus minus 3, then there it is positive here. Okay, plus 4, so add two zeros here, and similarly here 1100. And for this 750, so 1500, 2250, here it will be 150 minus 150 or something, and at the last it will be, sorry, 150 only, and the last it will be 1400. Okay, here it will be 2350. Now assuming that rupees 700, so let's assume that whatever the cost, that is 700 or 750 coming here, that is uniformly distributed throughout the project. Okay, so simple payback period will be, so simple payback period, what is the concept here? So bn upon cn. Okay, so simply you would need to divide the this by per year whatever you are getting. So here we are getting 700, 750, and similarly here we are getting 1150, let's say at the end of fourth year. So that will be because it is asking lifetime of 3 years only. Okay, so for project one, let's say one, So that will be 3 plus, so 3 years have already gone, and then 300, because at the end of 3 years it's 300, okay, and upon 700 is the income, so that comes out to be around 3.43. Okay, similarly for project 2, this will be 3.2 years, okay, and for project 3 it will be 3.13 years. So so the best, you can say the simple payback period, so best project is project 3. And now if you are going to discount it at the rate of 10%, okay, so 2400, and then you have to discount it at the rate of 10%, okay. So based on that, let's say this will be around 636. So use this formula to get the discounted payback period, okay. Okay, now net present value. The cash flows over the three project proposal during their lifetime of 3 years are given in the table below. So net present value, in this method, the present value of the future cash flow is determined by discounting, okay, and the costs are represented as negative values and savings as positive values, okay. So that's how it is done. And BJ minus CJ, so where BJ and CJ are basically benefits and costs, so benefits are basically savings, so they are positive values. And at the end of period J respectively, N is the useful life of the project, okay. So if CU0 is the capital investment and A is the uniform cash flow of the project, then C0 minus A 1 plus I, so I here is basically the interest rate, okay, which you can see in the previous question also. And then higher NPV is basically preferred. So the cash flow of the three projects are given here. Basically, it's the same question, and calculate the NPV of the project at the rate of interest of 10%. So please try to solve this question and see whether you are able to do it or not. So it's simple like previous question only. Just you have to put your mind and observe what is the present value of the project. So cash flows are given. Okay. So first thing is that key try to understand the question what it is asking, and then after asking you can always apply your different formulas that were given, and then you can get the values very easily. Let's say this is 2400 minus 2400. So first thing which you have to do is to get the what you say current value, a kind of discounted value. Okay, and then you after discounted value you can do the cumulative. So if you go for discounted value, this is 636 for first year. You guys are able to understand how I am getting these values actually. So the first thing is that key 700 is the amount, and then 1 plus I, so 10% is the interest. Okay, and that has to be n. So first year n will be 1, I equal to 10, so 10 by 100.1. Similarly, this is 578, this is 525. So these are discounted values considering the interest, and then uh, 478 is there for 700 at the end of fourth year, and then 434 is there, and then you get the cumulative values. Okay, so add all these values and then you will get 251 for this. For project 2 you will get something around 439, and for project 3 you will get 1057. So you can see the concept here, the net higher net present value will have the project will be preferred. So project 3 has the higher net present value, that is 1057, so this project is preferred over project 1 and project 2. Okay, so this was basically asked in the question. So this type of question will be asked in the exam also, so you have to be very cautious about solving these questions. What is being asked, if rate of interest is not given, you need not calculate the discount price, you just add up and simple calculate the simple payback period or something. But if it is given, you have to calculate according to the given formulas. Okay, Okay, so if there are no questions, should we move forward? So internal rate of return is basically it is the interest rate that makes net present value of an investment zero. Okay, and net present value of zero is the minimum value that would make the investment worthwhile. So mathematically, IRR is calculated as NPV I star. So basically, BJ minus CJ upon 1 plus I to the power j equal to 0. In other words, IRR is the interest rate I star that causes the discount value of the benefits in the cash equal to the present value of the cost. So this is kind of a concept which is very much utilized in benefit and cash expenses which we are going to do in the project. So now depreciation. So there are a lot of depreciation methods are there in the slides also, and professor has very beautifully taught these different methods. So I kind of took a question from the straight line depreciation method. So a solar still costs 4 lakh and has an expected useful life of 20 years. So its salvage value is estimated to be 20,000. Compute the depreciation and year-wise book value using the depreciation straight line method. This is kind of easy. You can easily calculate it basically. So try to do it and don't see the solution here. Just try to do it by yourself. And if it is not a straight line depreciation, if it's compounded depreciation or some other type of depreciation, so what will happen in that case? That also you have to take into account. So solve this question. This is kind of easy question, and I think you guys will be able to do it by yourself. Okay, so like say you just have to calculate the cost. So cost is 4 lakh, salvage value is 20,000, and 20 years is the lifetime. So divide the depreciation because it's a straight line depreciation. So every year a specific fixed amount will be depreciated. So that can be calculated using 4 lakh minus 20,000 upon divided by the number of years, that is 20. So 19,000. So initial book value is 4,000. So at the end of first year it's 4 lakh minus 19,000, 3 lakh 81,000 or something. And similarly for, okay, so similarly at the end of 20 years that will end up to the salvage value. Hello? I think that was pretty easy in calculating the depreciation using the straight line method. Now we move to the see is basically what happened. System. Just give me. Now we were talking about this straight line depreciation method, and then after that, uh, we'll move towards the techno-economic analysis. So whatever we had been studying throughout this net present value, all these things will be concept integrated into the techno-economic analysis. So techno-economic analysis basically you have the technical parameters and economic parameters combined. So effective crop residue availability, ith group can be calculated at this one. So effective net crop residual availabilities, that is also has to be taken into account when you are talking about the techno-economic analysis. Then from equation 1 and equation 2, which are basically effective net annual crop for bioenergy for district X, is calculated basically using these two equations. Okay. Then unit cost of production of biomass pellets can be calculated, and which is basically D into 1 plus D TBP, and TBP basically D is the discount rate, TBP is the useful lifetime of the biomass pellet unit. Similarly to equation for levelized cost of electricity that we actually studied, the ratio of total annualized cost of the biomass power plant to the annual amount of electricity produced. Okay, biomass power plant using biomass pellets as a feedstock. To annualized cost comprises annualized capital cost, annualized operation cost, annualized repair and maintenance cost. So annualized capital cost can be calculated as, so this is basically the formula for capital cost. So CI is basically 0.12 into 3.14, basically multiplied into rate, and then this is the annual cost which can be calculated, and hence the project has NPV of 1 crore 7 lakh 64,409. Okay, so this is for the year benefits. So cost what is incurred, and then benefits which are basically accrued. So NPV is basically calculated, and then uh, cumulative NPV is calculated. Okay. Now the last slide in the theoretical things which we are studying. So basically this is steps in the LCA. So LCA is basically life cycle assessment, where you take a life cycle approach where you get uh, the back end processor also, and what are the different impacts. So we have a scope here and goal. Okay, as the scope is defined, this is, and then functional unit, then we have inventory, so that also analyzed, and then impact assessment and interpretation of results are there. So basically in goal as scope we define the system boundaries, so it can be gate to gate, cradle to grave, mostly based on the mass and energy balance to quantify the input and output streams. Impact assessment is basically consolidating, identifying the environmental burdens of the input and output stream attained from the inventory balance. And some examples of impact categories are ozone depletion, climate change. So, okay, interpretation basically results from the impact assessment step are used to draw conclusions. Sometimes multi-objective optimization studies are done to choose among two options better in terms of environmental impact. Okay. So before going into next slide, if there are anything which you want to ask, so please feel free to ask here. Okay. Okay, so let's move to the NPV calculation. Now moving to the quiz questions. Which of the following represents the present value of the building operating plant over a assumed lifetime? So this was actually discussed. So most of the students will confuse it with net present value. So this is not the net represent the present value of the building and operating a plant assumed lifetime. So because it is levelized cost. So this is LCOE is the correct answer. Okay. Which of the following energy source has the highest net energy ratio? So net energy ratio is basically energy produced upon energy spent to produce it. So based on that, hydropower has the highest net energy ratio 100. You saw it here somewhere. Hydropower. Okay. Coal also has a very high net energy ratio. But all other things are quite low. Okay. Now moving to the next question. Which of the following option is an example of total energy approach? So there are different options here. So you need to actually think about what are the different examples of the total energy approach. I think you can come, no problem. Which of the following is an example of total energy approach? So, when we were discussing this total energy approach, so we are basically discussing about cogeneration. That is one thing where you are producing electricity and heat at the same time. Then we have multi-fluid coupled cycle like gas turbine and steam turbine cycle. Then continuous running a plant at maximum load is also one of the kind of total energy approach you can take. So all of the above is actually correct answer here. Okay. Now, cogeneration is defined as combined production of power and useful thermal energy by the sequential use of fuel or fuel. So this was actually taught in the lecture slides also, cogeneration. So think which is the correct answer. What is cogeneration? Basically, you have to think cogeneration. So something like cogeneration, if you break the word cogeneration, so generation like if you are generating electricity, and then cogeneration is something which is basically added up. Apart from electricity, you are getting something else also. So that is cogeneration. So cogeneration is basically the combined production of power and useful thermal energy. So yeah, this is correct answer. So correct option is true here. Net cash flow is receipt minus disbursement. So net cash flow, whenever you are going to calculate net cash flow, that is basically when you are calculating for any power plant or something. So whatever we are getting as a receipt, so there you use the term cash receipt, but it isn't only cash receipt. There can be any type of receipt in the account also. And then disbursement, basically the expenses. So net cash flow is basically receipt minus disbursement. So this is a correct answer. The condition for feasibility of cogeneration is, so this is one of the typical question which can be asked in the exam. So it's a very easy question. So the correct answer is NCO upon greater than NC. So you can actually, this was derived in the lecture slides also. The condition for project to be accepted, uh, so let's see, you guys try to get the answers for this. Okay, so correct answer here is basically answer A, and PB should always be greater than 0. So which of the following statement correctly explain the concept of life cycle analysis? So it is basically a way of figuring out the overall impact than a particular product, okay, environment and its entire existence. So correct answer is answer A. Now you have to calculate the future value of the investment amount of 15,000 compounded annually at the rate of 8% at the end of 5 years. So this is a simple compound interest question. Try to do it. हाँ लगभग 9 9 10 तक 9 15 तक हाँ कर लो कर लो ठीक है Okay, to solve this question, so this was very basic, simple formula based question. So just take the principal amount, which is 15,000, and sorry, 15,000, and then whatever is the rate of interest. So rate of interest is 8 upon 100, 8% is the rate of interest. Okay, and then end time is basically 5 years. So this is, so when you calculate this value, one, so let's take a calculator, 1.085 into 15,000. So that comes out to be around something around 18 something. Okay, so this is the correct answer. Similarly, you can calculate this payback period for a solar PV street light projects, which cost 95,000 estimated to last 20 years. So let's say saving in electricity is 11,000. Okay, so simple payback period which you just read in the lecture slides. So divide the whatever cost is there and divide it by 11,000. So that comes out to be around something 8.6 or something years. Okay. So 95,000 divided by 11,000. So 8.63 years or something. So correct answer is C. Now solar still cost 4.5 lakhs and useful life of this. So salvage value is this. Compute the depreciation and book at the end of first year using this straight line. So 4 lakh 50,000 minus 22,000 upon 20 years. That is the straight line depreciation that will go for every each year of what you say in the depreciation. So something around 21,000 when you subtract this 4 lakh 50,000 $22,000 from this value and divide it by 20 years, that will come out to be 21,400. So that is the depreciation value, and then you subtract this depreciation value from the total cost amount, so that comes out to be around 4 lakh 28,600. Okay, now consider the solar PV power plant that has a following cash flow for the different years. So this is the cash flow, discounted rate is this, find the NPV at the end of 5 years. So please So if there are no queries, then I think we can end this session right now. Okay. So thank you for attending this live session. So it was a wonderful interacting with you guys, and uh, the summary session will take place on 17th of October. So that will not be a live interaction session. That I will take select some um, numerical questions, and I will try to solve that. Okay. So okay, thank you for attending this live session.